Okay, so welcome to the ninth session. We are almost in the middle, and there will be 20 sessions in total. And so far we have been going pretty slow. And I hope you are understanding everything we have been discussing here. I just posted practice question set 2. That is related to kinematics. Because we are going to start dynamics, and this will take 2 to 3 days. 2 typical, 3 max. So quiz 1 that covers fundamentals, kinematics, and dynamics will be open after dynamics is complete. So that will take 2 to 3 days. For quiz 1, that will be the first quiz out of 3. So of course you have you can afford to perform poorly in one quiz, but that better not be quiz 1. You never know. So try your best, because this is the easiest part. And the quiz 1, these 3 units are the easiest ones, and we have spent a lot of time here. So I assume that you are better prepared for quiz 1 as compared to your preparation that can be for quiz 2 and quiz 3. So try your best to score 90%, 95%. It's not impossible. It is very easy if you just pay attention to what we have discussed in the class. So again, quiz 1 will be open in 2 to 3 days, and that will remain open for 2 days or 3 days max. So start reviewing the sessions if you have missed any. So make sure that there is not any topic that you miss. Quiz 1, how many attempts will be? Oh no, quiz is always just one attempt, single attempt. You don't get a second chance in quiz. You can review your attempt for sure, but just one. I'll give you all the detail when the quiz will be open. I'll even tell you that what topic is related to what question. For example, question 1, 2, 3. I'll give you the whole detail. You'll have that detail for quiz 1 and quiz 2, but not for quiz 3, because quiz 3 will be covering all physics 1. So that doesn't make sense to give you that kind of detail. That is actually a preparation for the exam, you can say a pre-exam. So for quiz 3, you will not have that information, but for quiz 1 and quiz 2, I'll give you a table. In that table, I'll tell you that quiz 1 is from this topic, and is it conceptual or a mathematical problem? So that will also be there. So all that information is provided. For quizzes, my typical time allotment principle or rule is that I set 4 minutes for a mathematical problem and 2 minutes for a conceptual problem. So conceptual problem should not take more than 1 minute, because you need to make sure that you read the problem at least twice, and then you answer it, and still it should be within a minute. So you save some time from conceptual problems, and you can utilize that time to review your attempt, or if there is any difficult mathematical problem, you can use that time there. Anyway, I'll give you all the details. So quiz is 1 attempt, no multiple attempts, and you will be able to review your attempt, and that will be open within 2 to 3 days, and will remain open for 2 to 3 days, and that will cover unit 1, 2, and 3. So start preparing for that. And again, practice question set 2 is available, and that is due by Thursday. So by the midnight Thursday. And that is kinematics, so shouldn't be a problem. And we'll be revising a lot of kinematics principles or concepts in this dynamics. So I told you in unit 2 that dynamics and kinematics both are related to motion. And what is the difference in kinematics? You have noticed that we were dealing with 3 equations of motion, and never we discussed that where is that motion coming from, what is the cause behind that motion. We were never worried about the force behind that. In dynamics, we'll be discussing the motion in reference or in relation with the force behind that. So that makes it dynamics. Greek word Dynamicus means powerful. It is one step ahead of kinematics because in this you are studying the cause of motion as well, the force behind. Force is a vector quantity because it has intrinsically a direction. When you apply a force, it is always in a certain direction, and the direction is very important to understand the impact of the force. If you are pressing something downward, you cannot expect that to go along negative x-axis or positive x-axis. So the direction is important, so that means that force is intrinsically, again, vectors and scalars are the vector and scalar by birth, you can say. It is their intrinsic property. You cannot just convert a scalar to a vector by just putting a direction to that. No, that doesn't work like that. Newton's laws will be important here. We'll discuss those. Free body diagrams are interesting and helpful in solving the equilibrium problem, especially. So again, when we get there, it will be pretty much the last part of the unit. So let's start. Force, that is our new friend here. A force can cause an object to change its velocity or shape. We are not much concerned about the shape part at this time, so we'll be focusing at the velocity. If there is a change in velocity, it can be changing direction. For example, circular motion, the magnitude part of the velocity remains the same because the object, for example, if you attach a string to a stone and you move that in a circle, and you keep moving this with a constant speed, the magnitude part of this motion is constant, but it is changing its direction at every moment, every instant. So its velocity is changing because the direction part of the velocity is changing. The magnitude part remains the same, but the direction part is changing. So velocity is changing in a circular motion. Similarly, if the car is traveling along a road, along a straight line, let's say positive x-axis, and it keeps going without any change in direction, without any change in the magnitude part of it, it means that there is no force acting on it. This is scientifically wrong when we say that there is no force acting on it, because if there is no other force, at least gravity is working on it. So the better way to present this fact is to say that net force on an object is zero. It means that we accept the fact that the object is under the influence of multiple forces, but the net impact of all the forces is zero. That's why the object is going on, moving along the straight line. No direction change, no magnitude change. However, if you apply brake or you speed it up, you notice a change in the velocity. Excuse me. So we have already established that whenever there is a change in velocity, it means that there is an acceleration. If there is no change in velocity, then acceleration is zero, right? So the change in velocity means now the object is still moving along a straight line. So now this time, the direction is constant, but the magnitude part is changing. So again, some force is involved here. So these are two cases. And the third case is when both the direction and the magnitude are changing. So that gets more complicated. So we are not going to discuss that part as such. So force, again, that can cause an object to change its velocity. We are not worried about the shape part here. F is equal to ma. Beautiful equation. Just three quantities related by this equation, and that equation governs the whole world around us. F is equal to ma. What does that mean? M is the mass of the object, and a is the acceleration, and F is the force. So if I apply some force on a 5-kilogram box, of course its velocity will change. If it is sitting there, then it will start moving. If it is already moving and I apply force in the direction of its motion, then it will speed up. If it is already moving and I apply that force in the motion in the direction opposite to its motion, then it will slow down. So there is some acceleration. So how can I find that acceleration? Using this equation. We know the force, we know the mass, we can find acceleration. Or if we know the mass, if we know the acceleration, we can figure out the force. So we'll be doing this a lot. Fun time. At 40 miles per hour, what will happen to your car if no force is applied? So first answer this. You are driving your car, you lift your foot off the gas pedal. What do you expect? What will happen? The car will keep moving, or slow down, or turn around, or start moving backward. What will happen? Okay. Slow down part is good, but zero acceleration, that is what we have to talk about. So second part of the problem, it depends if you're driving downhill. Okay, let's assume that it is a plane, no inclination, no upward, no downward. Yeah, good catch. Okay, now, so we know that, yes. Okay, yeah. So what will happen to your car if no force is applied? Means that you are not applying any force, so it will slow down. Okay, but F is equal to ma tells us that if you are not applying any force, then it has to be zero acceleration. Zero acceleration means that there should not be any change in velocity. That means that if the car is traveling at 40 miles per hour, it should keep moving at 40 miles per hour. This is what F is equal to ma tells you. So if something is moving at 40 miles per hour, you remove all the force. You make the net force on that object equal to zero. Then the car should keep moving at 40 miles per hour. It is a bit hard to grasp that, okay, if we are not applying any force, then why is it moving at 40 miles per hour? Well, think about the rocket, but we'll talk about that later, and that will make sense very soon. But here, first, this apparent contradiction. What does F is equal to ma suggest? F is equal to ma tells that there should not be any change in velocity, but it happens differently. Exactly, very good. There is resistance involved. So even if we are not applying any force on it, we have lifted our foot off the gas pedal, the resistance part is a negative force. It always acts in the direction opposite to the direction of the motion. If something is going along positive x-axis, resistance will always be along negative x-axis. If something is going along negative x-axis, resistance will always be along positive x-axis. So there is an opposing force that you cannot get rid of. That opposing force, that resistance is coming from the tire to road contact, the resistance and the internal resistance of the parts, moving parts. That's why, the rail car, you have metal wheels that reduces that resistance part. Just a side note. So this means that if you want to keep your car moving at 40 miles per hour, you need to compensate that resistance. Because if resistance is, let's say, negative 10 newtons, and you measure force in newtons, and we'll talk about that in detail very soon. So if the resistance is minus 10 newton, then you have to apply plus 10 newton force by pressing the gas pedal a little bit, so that your car keeps moving at 40 miles per hour. That's exactly what the cruise does, the cruise mode of the car driving. I love that. I even keep using the cruise mode inside the city. That is the most economical way. Okay, so that is where you see an apparent contradiction, but that should make sense after this explanation. Now let's talk about the force. As I just mentioned, that the unit of the force is Newton, and in everyday life, we can feel or make sense of some quantities very easily. For example, if I tell you that I have a 1 meter wide desk, then you can imagine that, okay, how long will be 1 meter? Very easy. Similarly, if I tell you that the mass of the table, the desk, is, let's say, 60 kilograms, you can make sense of that because you have felt 1 kilogram, 5 kilogram, 10 kilogram, or pounds. So that's easy. But force is a bit different, and in this unit, we'll try to make sense of force as well. And then at this point, the Newton, which is the unit of force, that may not make sense to you, but very soon you will be understanding that very well. So, force on a body. Now, our first object here is to figure out the net force on a body. Of course, like as I said, every object is at least under the influence of gravity. So you can see that there are multiple forces acting on a body. So we need to find out the net force. The simple way is to just use what you do with a vector. Resolve that into its components. Okay? So we have a force F here making an angle theta with x-axis. So it has two components, just like vector components. It has the vertical component Fy and horizontal component Fx. Okay, it doesn't make much difference if you move this Fy here or there. And now we have another case here. What if we have multiple forces, F1 and F2? For example, I have a block here. I have two strings attached to that. One string I am pulling in this direction. The other string you are pulling at some angle. And I need to find out that, okay, well, both of us are applying some force on this object. So what if I want to replace these two forces by an equivalent force? That I take these two strings out and I replace that with single force that is equivalent to these two forces. So how can I find out that equivalent force? Technically, we call it a resultant force or net force. Okay, so for that, again, you can use head to tail rule because that's how we solve vectors. So we have F1 here and we have F2 here. So for head to tail, you have to connect the tail of the vector to the head of the other vector. So you just move this F2 over there and you have head to tail configuration here. In the end, just connect this tail to this head, and you have this F vector. That is the resultant of these two vectors. Now the thing is that in Physics 1, we won't be using graphical method a lot. We'll be mostly relying on the mathematical method. So let's learn about that. That is actually more interesting. But now you are going to get your hands a lot dirty with trigonometry, and that will be fun. Trust me. I hope by now you have a very good understanding of trigonometry and you can use those concepts here. If not, then please review the session and go through the practice questions, and you should be ready for this. In this particular case, we have three forces. One force is F1. That is 120 Newton, and it is acting along positive x-axis. The other force is F2. It is making an angle 60 degree with x-axis, and the magnitude of this force is 200 newtons. The third force is F3. Its magnitude is 150 Newton, and it is making an angle 45 degrees with negative x-axis. Now, here is a problem. I can get away with this. Okay, I gave you the information, or you deal with this. But the problem is that you cannot have multiple reference points to solve single problem. As I discussed that in the past, that for most of the time, and especially in Physics 1, this will be our convention, that our reference axis, the starting point of any angle, will always be positive x-axis. Not always, but almost always. So 60 degree makes sense. It is starting from plus x or positive x-axis. It is going in counterclockwise or anti-clockwise direction. So 60 is good, but 45 we got problem there. We have a 45 degree angle. Okay, it is going counterclockwise and anti-clockwise, so that's fine, but it is not. The reference is not positive x-axis. So what will be the angle for the sake of a problem, mathematical solution? That will be 45 over here, but we have to add 180 from this one. Because if we want to use positive x-axis as the reference, then we have to add this missing part too. So now we have 180 degree coming from here, and then 45 going this. So now we have a complete angle that makes sense. Now we can tell that, okay, now we know F3 is making 180 plus 45 equals 225 degree angle with positive x-axis. Is that clear? Please confirm. Quick. Okay. Just to give you another example, just to let's say we have this scale, and that is our 0. I'm just being lazy, not typing the number, and that is our 1, and that is our 2, and that is our 3, that is our 4, and that is 5. Okay. Now, if of course we know that our reference point has to be 0. That is generally accepted rule, right? If I say that, okay, I am standing at 2, I started from 0 and I'm at 2. So taking 0 as a reference, I am 2 steps away. But if I started from 3 and I went to 4, and I'm telling you that, okay, I just moved one step and I went from 3 to 4. But our reference is 0, it's not 3. So what you have to do, you have to add this part as well in my displacement from the actual reference point. So that will come out to be 4, and that cannot be equal to 1. It's not right, because we have to consider this missing part as well, because the reference is standard over here. So that is the same thing I'm doing here. The reference is standard positive x-axis. If you started measuring your angle from negative x-axis, that's fine, but then you have to cover that missing part as well. So 180 from here, and then you add 45 in there, and then you have 225. Another possibility is that if you are given a negative angle, and we have already discussed. So now, let's start our standard procedure here. So we have 3 forces. We know what is the angle, what are the angles, what are the magnitudes, and we need to find out net force. So if we want to find out the net force, it will essentially have 2 parts. One is the magnitude part, other is the direction part. And in mathematical methods, we use angle to describe direction. So let's start. To find the magnitude part, what we do, we tear apart all 3 vectors, all 3 forces into the components. So F1, we have to find out its horizontal and a vertical component, x and y component. Similarly for F2, similarly for F3. So we'll find out x and y components of all 3 forces. Then, what are we going to do? We'll add all the x components, and that will give us the x component of the net force. Then we'll add all the y components, and that will give us the y component of the net force. Okay, let's start. F1. let's say the x component of f1 is f1x over here. So we know that to find the horizontal component of a vector, the formula is the magnitude of the vector multiplied by cos of the angle this vector is making. Okay, so what is the magnitude of f1? That is 120. Cos of angle is 0 degree. So cos of 0 has I told you that these are simple quantities, so I expect you to memorize these. So cos of 0 is equal to 1. Okay, so 1 multiplied by 120 is equal to plus 120 newtons. F1y. So this is the y component of F1. Again, magnitude. For the y component, you have to multiply the magnitude by sine of theta. For x component, it is cos of theta. For y component, it is sine of theta. So 120 sine of theta. Sine of 0 degree is equal to 0. So 120 multiplied by 0 is equal to 0 Newton. And that makes sense. Now we have the mathematics here. Now let's try to make sense of this. We know that F1 is totally along x-axis, so it has an x component, and this vector is totally along x-axis. This vector does not have any y component, right? So this is what we see in the mathematical handling over here. No y component, it's totally x-axis. Now, let's talk about F2 force. So what is the x component of this force? That is F2 cos of the angle. So cos of 60 degree is 0.5. Okay, so 200 multiplied by 0.5 is equal to 100 Newton. Now F2y, the y component of F2. 200 multiplied by sine of the angle. Sine of 60. Sine 60 degree is 0.866. So when you multiply that by 200, you get plus 173 Newtons. Now, let's talk about how come we did not use 60 degree for F1. Because what is the angle F1 is making along x-axis, with x-axis? That's it. Yeah. Yeah. So you just look at how far the vector is away from the x-axis, and that will tell you what angle is this. This is the concept of angular displacement. I will talk about that in another unit. Okay, now F3. So the x component of F3 is F3x, and we have already figured that the angle is 225 degrees. Paul, you have a question? I see a click next to your name. Okay. Paul, how do you determine F1x and F1y? Again, the typical method is F or any vector, let's say A. This is what we have already learned. Okay, so that's what I'm doing. F1x is equal to F cos of theta. And theta is 0 degrees. So 120 cos of 0. Cos of 0 is equal to 1. So that's how I get 120 here. And sine of 0 is equal to 0. So that's why we have 120 multiplied by 0 is equal to 0. Is that clear enough, Paul? Good. Okay, where is the confusion? Tell me. Okay, do one thing. If If you have the calculator, fine. If you are if you don't, then on your computer, open Google and switch the just type cos of 0 degree. Enter this and get the answer. What answer do you get? Just Google it. Good. Paul? One. So does it make sense now? Okay. And now search for this sine 0 degree. Again. Okay. At last. So sine of 0 degree such that 0. Right. So 120 multiplied by 0 is equal to 0 Newton. Any confusion or any question now? All good? Good. Okay, now, so we did the same thing with F2. F2, the x component was F2 magnitude multiplied by cos of the angle. So 200 multiplied by 0.5, 100 Newton. F2y was 200 multiplied by sine of 60 degrees, that is 0.866. So multiply by 200, you get 173. Now F3, that is interesting part. Okay, at this point, keep checking the physics of this, and keep checking the validity of your answers. F2x, you're getting a positive F2, the x component. So does it make sense? Yes, F2 is over here, so its x component will be along the positive x-axis. Its y component is along positive y-axis. So yes, both should be positive. That makes sense. Good. F3x. 150 is the magnitude of F3 multiplied by cos of the angle. Angle is 225 degrees. Now, what is cos of 225? Let me just double check. Cos of 225 degrees. It is minus 0.707. Okay. Now I multiply that by 150. So answer is minus 106.0660. Just drop everything and you have minus 106. Same is the answer for F3y because sine of 225 is also minus 0.707. Yes. So in both cases we got minus 106 newtons. And now does that make sense? Let's check. F3 is over here. So its x component is certainly going to be along negative x-axis, right? Its y component is going to be along negative y-axis. So both these components have to be negative. That makes sense. Now, now we want to know the x component of the net force. They pull it opposite. Yeah, exactly. These forces can be in any direction. Who cares? We just need to find out the net force. So now we are going to add the respective components. So for the x component of the net force, add all the x components here. So 120 plus 100 minus 106. When you solve it, you get 114 newtons. For y component of the net force, 0 plus 173 minus 106, you get 67 newtons. So now you have the two components of the net force. Now you are going to find out the net force. So first, we had the forces in pieces. We broke those pieces down into components. We solved those components, Now we are combining those components together to get the x and y component, and from the x and y component we are going to generate an actual force, the net force. So how to do that? X component squared plus xy squared whole square root. It is again the old story, Pythagorean law, trigonometry, distance formula, all displacement formula as well, going all in the same direction. And this is, if you have the x component, if you have the y component, this is how you get the vector itself. Yeah, exactly. Yeah, you're right. Especially when you have you are dealing with Cartesian coordinates, so you have x component and y components. So essentially, x component is the adjacent, and y component is the opposite. So yes, the vector itself comes out to be hypotenuse. Very good. So we just put the values here, we solve it, and we get 132 Newton. So net force is 132 Newton. Now you can see that, okay, it is making sense because 200 is in this direction, and then we have opposing 150, but then we have 120 over there as well. So this is kind of making sense to us that net force should be in the middle somewhere. Now, theta, what is the angle? It is tangent inverse or arctan of y component divided by x component. So if you solve it, you will get 30.4 degrees. So the net force is somewhere over here like this. So you can take all these force away and just keep this one force with magnitude of 132 Newton and making an angle 30.4, and the situation will be the same. The body will be moving with the same acceleration as it was moving under the influence of these three. Any question or confusion at this point? Please let me know. Okay, first about the tan. This is trigonometry, and I explained that, but let's do it again. New page, and we have a right angle triangle here. So this is our adjacent, this is our opposite, and this is the hypotenuse, and this is theta. Okay, now what is tangent of theta? Because the thing is that in such problems we are given the adjacent and the opposite, and we want to know theta using these two pieces. These two are actually the y component and the x component. Okay, so now what is tangent theta? So tangent is equal to opposite divided by adjacent. Okay, so let's type it. Tangent of theta is equal to opposite. So what is opposite? Opposite is basically a y component of the force. So xy divided by adjacent. Adjacent is x component of the force, fx. Now, if you want to find out theta, then what you have to do? You have to do tangent inverse on the both sides. So tangent inverse of tangent theta is equal to tangent inverse of fx divided by fy divided by fx. So crudely speaking, not really, but crudely speaking, these two will be cancelled out, and you will be left with a t over here. So t is equal to tangent inverse. That's why I used theta is equal to tangent inverse of the y component divided by x component. Does it make sense now? Okay, the next question is 225. The main rule is that your reference point is this axis, positive x-axis. You cannot move the reference point around. Okay, so all your measurements start with 0 when you are taking length. If you are measuring the width and length and height of your desk, you cannot take one measurement starting from 10 and other starting from 20 and the third one starting from 0. You will not be able to compare, you will not be able to make sense of these. All the readings must have a reference point that is 0. Does that make sense, Maria? Okay, so when we are dealing with the angles, the angle starts from positive x-axis. On positive x-axis, it is 0. Find out. I think, but I have something. So, this is our x-axis. So, x-axis, the angle is 0. Now we start moving it. So it goes 20, 30, 45. 45 it will be in the middle somewhere. 60, 75, and this is the right angle, that is 90 degrees. Now we keep going, and then we reach over here. That is negative x-axis, 180 degrees. We keep going, and 150, 160, 270 degrees over here. And we go all the way back, and we reach 360 degrees. That is the same as 0 degrees, right? So this is what's happening here. Angle starts from here, and if you want to know what angle F3 is making with positive x-axis, you need to find this whole dashed line. You cannot just consider 45 degrees. Now, because the only information we are given in the question is that this angle from negative x to the vector itself is 45 degrees. Now we have to figure out the rest of the vector by ourselves. What is this vector, this angle from positive x to negative x? That is from 0, 90, 180. So we have to add 180 to this 45, so then we have 225. Okay. Now it's my time to take revenge. Why did you ask this question? Now, let's check if you got it. So here I have a vector, and the angle over here is, let's say, 60 degrees. And this is our x-axis. So what is the actual angle I can consider for my calculation? What is the angle this vector is making that I can use for my mathematical calculation? It's for everyone. 90? No way. Okay, after we do this example, then you will figure. As I said, the angle has to start from positive x-axis, right? So what angle is this area? Yes, it is 30 degrees. Okay, because this total angle is 90 degrees. So I am given this piece of information, 60 degrees, but that doesn't help me. I cannot use this information because the angle I want is starting from positive x-axis, going counterclockwise or anti-clockwise. So I have to shift my reference and I have to check, okay, what information do I have? I know that this y component, this y-axis is making an angle of 90 degrees with x-axis, so total angle over here is 90 degrees. Out of that, this part is 60, so this part must be 30. So this is the angle I want. Now let's solve another problem. Yeah, what is my angle to work with? The angle will be starting from positive x-axis going anti-clockwise. No, it was not 90. It was 30 degrees. Because I need to know what angle that vector is making. Not starting angle, it is the actual angle. Because 30 degrees is the only angle it made. So the vector started from x-axis, went this much. This angle is 50 degrees. So this must be 30 degrees. This is what, yeah. Upward or, correctly speaking, it should be anti-clockwise. Yeah. Okay, now we have this vector here, and this angle is 15 degrees. So what angle can I use for my mathematical solutions? When I'm solving the problem, what angle should I pick? Okay, a hint. What angle is that vector making with x-axis, positive x-axis? This is the vector. The angle should always start from positive x-axis. We are given this 15. So we have to add this 90 as well. So the answer will be 90 plus 15 equals 105. So this actual angle the vector is making with positive x-axis is 105 degrees. Is that clear now, okay? I won't take it as compliment. I'm translating as that's the angle was the question was confusing. The reason is that I cannot say that what angle is that vector making with positive x-axis. Then I am telling you half of the answer already. So instead of that, I'm using the sentence, the phrase that what angle can I use for the solution when I am working on that. So now let's work on another one. So this is a vector, and this angle is 60 degrees. So what angle can I use? What is the actual number that I can use for solution? Cosine, can it be 180? If it was 180, the vector should be along negative x-axis. Do you think so? Mm-hmm. Quick. Yeah, but what I need to know, that what angle is that vector making this x-axis. So I don't really need to worry about the 60 degrees. This is what I need to know. Okay, so this is 90 degrees. This is the typical way to represent 90 degree, where you just make a box like this, and that makes that it is 90 degree. Now, how much is this part? This is what I need to know. Because this part is 90, out of that, this part is 60, so this part has to be 30. Exactly. So 90 plus 30 equals 120. So that's how you find out the angle. Now let's play one more game and then we move forward. Now I'm going to raise the difficulty level. Here is the vector, and this angle is 40 degrees. Now, what should be the angle? What I can use for my calculations? So you will only calculate after the before the. No, I'll explain that again. The actual angle you need is starting from positive x-axis going all the way. Excellent. Okay, so you can solve it two ways. One is that we know that the total angle from here all the way there is 360 degrees, right? If this vector is 40 degrees short of 360, then it has to be 320, like 360 minus 40 is equal to 320. The other method you can use is from here 90 plus 90, 180 plus 92, 70, and then how much is this one? Because the actual angle we need to know is starting from x-axis. This is the about setting the reference right. Okay, so reference is always positive x-axis. So you have to go all the way from there and reach here. So if this one is 90 plus 90 plus 90, 270, and this much, but because from here to there it is 90 degrees. Out of 90, this is 40, so this has to be 50. So 270 plus 50 is equal to 320. Okay. So that's how you solve it. 180 plus 90, 270 plus 50. Exactly. Very good. Yeah. Okay. So when you are solving these problems, make sure you get the reference right. Okay, let's take a 5-minute break. Read and read again. Let's take a 5-minute break and see you then. Okay, now Newton's laws of motion. Just because he born at that time, so he found these things he just said, and he took his name with these laws. Anyone could figure that, you know. We'll study and then you'll figure out that, yeah, anyone could say that. So the first law of motion, if net force is zero, okay, net force is zero, as I said, that every time every object is under multiple forces. So if there is no other force, then at least gravity is there, as long as we are on the surface of the earth. Even if we are in the space somewhere, there is no place where there is no force. Okay, so we are always under the influence of some force. So that's why we use the term net force. Net force means the resultant, the addition, the sum of the forces. If net force is zero, A stationary object will remain at rest. If something is at rest, it will remain at rest. And a moving object will continue to move with no change in velocity. In short, if there is no force, there is no acceleration. Simple as that. Okay? So that's how we also call it law of inertia. And that's why you are always advised to take care of your seatbelts. You cannot ignore that part when you are driving, because then when your car comes to an abrupt stop, the car stops, but your body keeps moving. Okay, because the car stops because of the direct impact with some object, and your body keeps moving. So if you don't have your seatbelt on, you can crash head first into the windscreen, and that is the cause of the death most of the time, or serious injury. If you are in an accident, no one can assure zero damage. Of course, it is an accident. You are going to get hurt a bit, but with the seatbelt on, you don't have to face that much agony, you can say, that much danger. So please always keep your seatbelts on, even if you are in the parking, even if you are just leaving your driveway. I have my friends, as soon as I pull in the driveway, they just take the belts off. What if at that time some car hits you? It's not your fault, but some other object can come and hit you. So stay safe. No net force means no acceleration, so no change in velocity. Yeah, it becomes exactly. Either no force or some of the force is zero. Friction, in addition to other, is main cause why we don't see this in our everyday life. We just discussed that in the beginning of this session, that why we don't see the car moving, keeping on moving if we take the foot off the gas pedal. Initial frameworks, just drop this, it will be more confusing, so I'm just going to cross it off. Okay. Now let's talk about the applications of first law of motion. And now when you see around, you'll see, haha, that person is following first law of motion. Don't say that. People will call you crazy. Just enjoy that these things are happening around us. Dogs know Newton's first law of motion. At least they use it when they are wet. So what do they do when you are giving your dog bath? So what does the dog do? They shake themselves, right? So when they shake it, they take yeah, that's another thing. So when they shake the body like this. Okay. So when they move their skin in this direction, they take the water along, and then they suddenly stop and they come back. The water droplets keep moving. So what happens? They get off their fur. During takeoff, as the plane accelerates, passengers feel a backward push. So this is another, because you are stationary, so you want to stay at rest, but it's not your choice, it is natural. You feel a forward push when you apply brakes. Again, we just discussed that. Stamping your shoes to get the snow or mud off. Again, because when you're stamping your foot, you're bringing like faster, and then it comes to abrupt stop. So what happens? The mud or the snow, whatever is sticking to your shoes, it keeps moving, and your shoe has stopped, so it comes off. So these are just a few examples. Push a cart. It does not keep on moving because the resistance is there. Don't push accelerator, cars stop after some time. Again, no car stops. It should be either cars stop or car stops. So let's take one off. After some time. So yeah, exactly. Another example. Here's the second law of motion, and that is very closely related to the first law. As a force acts on a body, acceleration is produced. This acceleration is directly proportional to the force applied and inversely proportional to the mass of the body, and it makes sense. Let's say you are applying equal amount of force. So we have a small box and you apply some force on it, and then we have a big, huge, heavy box and you apply some force on it. And you can tell right away that the acceleration will be smaller in the bigger box. So it is inversely proportional to the mass. On the other hand, if you have two objects of the same mass and you apply different forces, the one with more force will have a more change in more acceleration, more change in velocity, more significant change in velocity. If multiple forces are involved, then sum of all the forces is equal to ma. And the beautiful part of it is acceleration itself. It is a vector quantity, so you can break the whole problem into coordinates. If you just take all the x components of the forces, that will give you the x component of the acceleration. Beautiful. Same is the case with y. Same is the case with z or c. So we're not going to get to this part. Now let's talk about an example here. A box of mass m is equal to 10. Okay, before that, let's think about a simpler problem. Just using f is equal to ma. Remember, f is equal to ma. Okay. Now we have a box sitting here, and the mass of the box is 10 kilograms, and again it is sitting there. And for these problems, we assume that there is no friction at all between these two objects. Okay, so when I say the word it is sitting on a smooth plane, that it means that friction is ignored. Of course, in the later stages we'll discuss friction as well, but for now, no friction. So okay, we have a 10 kilogram box here, and I apply a force uh, 20 Newton on it. What will be the acceleration? F is equal to ma. I need to know acceleration. F is equal to ma. F is equal to ma. Masters of Arts. Okay, please try to provide the unit as well. So it is meter per second squared. Okay, 2. Okay. Yeah. Okay, let's solve it. And because f is equal to ma is easier to remember, so let's start with that. Ma, and just plug the values. F is 20 newtons, is equal to mass is 10 kilograms, and a we don't know. So dividing both sides by a. Sorry, 10. So it will be 20 by 10 is equal to a, or rearranging, a is equal to 2 meter per second square. Good job. Okay. I love it. Now let me tell you why. A is equal to 2 meter per second square. I can assume that may not be making sense to you. What does that mean, 2 meter per second square? Now, what is that? It means that the change in the velocity is 2 meter per second every second. Okay, now what does that mean? If this box is stationary, its initial velocity was 0 meter per second. So if you are applying 20 Newton force on it, after 1 second, what will be its velocity? Because acceleration is 2 meter per second squared, it means that the change in velocity is 2 meter per second every second. So initially it was 0. It will be 2 meters per second after 1 second. It will be 4 meters per second after 2 seconds. It will be 6 meters per second after 3 seconds. So that's what A is equal to 2 meters per second squared means. Does it make sense now? And did this reduce your hate for math or not? So it is just that you need to understand that what these numbers are telling you. How can you translate that into your everyday experience? How can you translate that into English, basically? Yeah, exactly. What you can tell, no, what will happen? When you get tired, you'll stop applying force, right? So the body is already traveling, moving at 6 meters per second after 3 seconds. At that point, we just cut the force, we stop applying because we got tired. What will happen? The box will keep moving at 6 meters per second along positive x-axis because no force, no acceleration. There is no force of friction, and we have already established that. It is smooth surface, so the box will keep moving at 6 meters per second indefinitely until you go, you grab water, you drink some, and now you're fresh, you come back and you apply opposite force to stop that. Is that part clear or not? Because from our everyday life experience, it is hard to grasp the idea that how can a body keep moving if you're not applying any force on it. So the key part here is that there is no friction involved. If there is no friction involved, then the body will keep moving indefinitely. Okay, now let's go back to this problem. Now, a box of mass M is equal to 10 kilogram rests on a smooth horizontal floor. Smooth means no friction. Okay, would acceleration ever be kilometer per hour? So we correlate it to real life? No, it will not be. You can convert that, but in kilometer per hour. Yeah, you can convert that if you want, but the standard units are meter per second squared. So we usually use that. And just go to Google, and for example, we were talking about 2 meters per second squared. So type 2 meters per second to kilometer per hour. It is 25,920 kilometers per hour. Okay, so rather than looking at this scary number, we better stick with 2 meters per second. Okay, now a box of mass M is equal to 10 kilogram rests on a smooth horizontal floor next to a box of mass N is equal to 5 kilograms. So we have 2 boxes here. A force F is equal to 20 Newton is applied as shown in figure. So what is the acceleration of the boxes? Now the thing is, if you're applying force over here, it has to move both boxes, right? So the net mass you are dealing with is 15 kilograms. And how much force block B is exerting on block A? Because of course it is trying to stop it. So let's do the first part first. F is equal to MA, or A is equal to F over M. Force is 20 newtons, and mass, as I told you, total mass is 15 because we are trying to push both boxes altogether. So 20 by 15 is equal to 1.3 meters per second squared. Now, force by block B, because both boxes, they are undergoing the same acceleration, they are moving together. So acceleration is 1.3 meters per second squared, but in case of B, the mass is 5. So just multiply and you get 6.5 newtons. Very simple problem. Just need to understand that the physical situation, what is going on there. Now this is the interesting one. This is where you'll see that how kinematics evolves into dynamics. Okay. Let me check how much we have. Let's solve this problem and then we'll stop. So a jetliner begins to slow down after landing. Okay, from this, just this much, after reading this much, can you tell me anything about any of those 5 quantities? Do you have any information? What can you tell? Let me write those down. VI, VF, S, T and A. Now, a jetliner begins to slow down after landing. Does it tell you anything about VI or VF or S or T or A? Even the nature of it, even the direction of it, even the sign of it, any information. What do you think? Excellent, excellent. Yep, acceleration is going to be negative. It is slowing down, okay? At every instant, final velocity is less than the initial velocity, so acceleration is the difference, so it will be negative. Very good. Its mass is 3.5 into 10 to the power 5 kilograms, and speed, velocity but speed, okay, is 27 meters per second. Net braking force, so now here we have an opposite force coming in action. Net braking force, it means that the force is acting opposite, in the opposite direction. The plane is going there, this braking force is in that direction. If the braking force is also in the same direction, then the jetliner will be speeding up. This should make sense. So what is the speed after 7.5 seconds? Now let's try to solve this. First of all, tell me what information do you have when you start reading. What is the first number you see? Let's do that drill. First information, what is that? Okay, mass, very good. By the way, mass is not one of those 5 quantities, but it's fine. I take it. M is equal to 3.5 into 10, excuse me, this for 5 kilograms. What is the next information? Is it S? Yeah, so pick one of these 5. We are dealing with these 5 variables, like kinematics variables. So one of these. It is VI. Very good. So VI is equal to 27 meters per second. And what is the next information? We are solving part A for now. No, we do not have A. It is force, yes. So F is equal to 4.3 into 10 to the power 5 newtons. And what is the next piece of information? We are solving part A, so just ignore part B. Okay, I'm breaking it up. Now, we don't know. Does it say that? I don't think so. It's about the scope. Within our scope, it is not coming to stop. Eventually it will. Yes, T is equal to 7.5 seconds. And Maria yeah, you are all right. It is VF we need to find out. So it will be VF is equal to this question mark. And that is a typical dynamics question, because the problem here is that we cannot use any of those equations. Let me grab that quickly. Here are the equations. Snip tool. Okay. Next, here we are. Okay, now the problem is, if you consider first equation, Vf unknown, Vi we know that, A no idea, T we know that. So two unknowns, we cannot use that, out. Second equation of motion, S, who cares, not even asked, not provided, out. Vi, we know that. T, we know that. A, we don't know that. T, we know that. So S and A both, we don't know, out. Yeah, exactly, we want Vf, so that's another reason, because second equation of motion does not give us Vf. Good, very good. Now third equation of motion, 2as, A we don't know, S, again we have no idea. Vf, Vi, we know, Vf is unknown, Vi we don't know. Sorry, Vi we know that, but Vf we don't know. So again, three unknown variables. So at this point we are thinking that we cannot use any equation. Now, what if we have acceleration and using F is equal to ma, because we know F, we know m, so using F is equal to ma, we can find acceleration. So once we have acceleration, then we can revisit these three equations and find out if that helps. So F is equal to ma. Let's check here. We start with the first equation prior to, yeah. Okay, so this is where I am trying to find out acceleration. So F is equal to ma. Force is 4.3 into 10 to the 5 newtons. Mass is 3.5 into 10 to the 5 newtons, and acceleration A. And A comes out to be 1.23 meters per second squared. And I keep asking you, keep telling you that you should always try to make sense of your answer and double check if it is making sense according to the requirement of the problem. Now, acceleration is 1.23 meters per second squared. Do you think it is correct? Okay, why does it not make sense? And I want input from all of you. If you think that it is correct, it makes sense, then okay, that is fine. But Kausika is challenging her instructor. That's not a good thing to do then. Okay, it's slowing down. Got to be negative. Okay. Any other opinion? Yes, that's exactly right. It got to be negative. It cannot be positive. If acceleration is positive, it means that the jetliner is speeding up, and that is not the case. So where did it go wrong? It went wrong over here. The force is negative force. It is not positive because it is braking force, right? So braking force has to be negative. So you cannot miss that part. You put negative there, and then it will start making sense. So A is equal to minus 1.23, and this is something that you can easily miss. Very easily you can put F is equal to a positive number. So this is the point where you can still save yourself and you can check, oh, does it make sense? No, it does not. So where did the negative sign get dropped? So this is very important exercise you should do. So here we have A is equal to minus 1.23 meter per second squared. Can we call it resistance? Very good question. Yes, you can call it resistance, but not in a very accurate ways, but you can call it. Because eventually it is the resistance of the parts, machine parts, that is doing this braking. So yes. If I say resistance, because I said that it is not very accurate way, that resistance is basically the resistance when your car is skidding, right? You have pushed the brake pedal all the way down, and your wheels are stuck, and still the car is skidding. So that's where we say, okay, there is some resistance coming in between the tire and the road. But if the car is, in this case, the plane is rolling, then I'm personally a bit hesitant to call it resistance. It is basically braking. You are applying brake. I don't know what does the brake look like. Maybe it's just a brake pedal like we have in the car, but whatever. But it is a braking mechanism that is working to slow down the jetliner, so it may be a bit more than resistance. Yeah. So we have A is equal to minus 1.23 meter per second squared. Now we go back and put the value here. A is equal to minus 1.23 meter per second squared. And now it will become a very easy to solve problem. Typical kinematics. Okay, yeah. So can we use first equation of motion? I guess we can. Yeah. Vf is equal to Vi, we know that. A, we know that. T, we know that. So we can use first equation of motion. Actually, third we cannot use because S is something we have no idea, and we neither require it nor we have the information. So third equation will not work. Second equation, Vf, we need to find out Vf, and well, the second equation does not involve Vf at all. So yeah. So second and third doesn't, both are not going to help. First equation, the simplest of these, is the one we are going to use, and just put the values, and you get 1. Wait a second. Here. Yeah, this one. So 17.77 meter per second. Okay. Always use physical understanding of the problem to verify your answer. Now, let's stop here. We'll do the second part later, and that is where we are going to find out the distance traveled in this time. Any question or confusion, please let me know. Okay, I'm going to stop recording here. If you want to stay, you have a question, you can stay. If you want to leave, feel free to do so. For those who want to leave, have a good night.